Hi, today we're going to look at rationalizing the denominator, and I will talk more about what that means in a minute. I think it's best illustrated through an example. So express 16 divided by root 8 in the form k root 2. How am I going to do that? What this question is saying is get rid of the fraction and somehow write it so it's no longer a fraction. And to do that, we're going to need to combine the worlds of surds and nice normal numbers, such as 16. And what we're going to do, actually, is we're going to multiply by something. But we need to multiply by something so that it doesn't change it. So actually, I'm going to write it out a bit more fully. 16 over root 8 equals 16 over root 8 multiplied by root 8 over root 8. I've essentially just multiplied by 1. But look what happens. The top becomes 16 root 8, and then the bottom becomes root 8 times root 8, which is root 64, or you could go straight to getting 8 from that. And we're well on our way to sorting this out. So now I can do 16 divided by 8, which is 2. I've still got my root 8 there, and I'm nearly there. I just need to get it in the form k root 2. So I've not done that yet. And to do that, I'm going to need to use one of my previous rules of surds. I'm going to need to write it as the square root of a square number multiplied by the number that's left. Okay, I've done that quite quickly, but I just need to recognize that the largest square number that goes into 8 is 4. So this here is the root of 4 times 2, which I can then write as this. And then the square root of 4 is 2, so it's 2 times 2, which is 4. So my answer is 4 root 2. I have got it in the form I've wanted, and actually I have rationalized the denominator. At the start, this was the denominator. It's the thing that is on the bottom of your fraction. And the square root of 8 is an irrational number. If you put it in your calculator, it goes on forever. I can't write that as a fraction. So by multiplying by root 8 over root 8, I've changed the denominator and I've rationalized it. 8 is a rational number because I could write it as 8 divided by 1. And then I've simplified it down. So I've done more than just rationalize the denominator, I've put it in a special form. But we're just going to focus on the more simple skill in a minute of rationalizing the denominator. But this illustrates that sometimes you do have to have extra working afterwards. Now, there's one more way we could have done this, and I do feel it's important to talk about. And you know, because if you spot this, you can do it slightly quicker, I think. So I could, from the start, have written it as 6 and said that 16 over root 8 equals 16 over, and then I could have written 4 times 2. Okay, because I know I want it in the form root 2, I'm already getting a root 2 in there. And then this would become 16 over root 4 root 2, which is 16 over 2 root 2, which is 8 over root 2. Now I've not got it in the right form yet, but I've kind of I've done the steps in a different way. Because now I can multiply, not by root 8 over root 8, but by root 2 over root 2. Why have I done that? Because the top becomes 8 root 2. I'm just multiplying fractions here, and the bottom becomes 2. And then again, this simplifies down to 4 root 2. So 2 different ways of doing this question. And that is what we mean by rationalizing the denominator. I did it right at the end in that case. Okay, we're going to look at 3 more examples. Rationalizing the denominator. What I'm going to do is I'm going to multiply by root 11 over root 11, because that's going to mean I get 11 on the bottom, and I can rewrite that as root 11 over 11. So these are the same thing. They look quite different, don't they? But they're exactly the same thing. I can do the same here. It's going to be 6 root 3. Guess what? I'm going to multiply by root 3 over root 3. And that's going to give me 6 root 3 over 3. In this case, I'm going to need to do a little bit of cancelling to end with. Okay, but these two are not quite as difficult as this first example that I spoke about. And then finally, this one. Okay, I've now got sort of this 3 plus root 3 on the top. Not just a nice number, but an actual surd. But that's okay. I'm only really interested in rationalizing the denominator. It doesn't matter that the numerator will remain or become irrational, which it has done on these other examples. Okay, I'm going to times by root 3 over root 3. That's going to become 3 plus root 3 multiplied by root 3 all over 3. Lots of 3's going on here. And then I'm going to multiply this bracket out. I'm going to get 3 root 3. And then plus 3 all over 3. And then what I can do is, well, one thing I could do is I could factorize out the 3 from the top and write root 3 plus 1 over 3. And I can cancel those out. And that's going to leave me with root 3 plus 1. Or if I was like feeling confident and I realize there's a plus, I can just sort of cancel these out. That's going to cancel with that and leave 1. But I also have to cancel that because there's a plus. And again, I get root 3 plus 1. So the long way is to factorize it and just be really careful, but you are allowed to do this sort of thing as well. Okay, 4 examples on essentially rationalizing the denominator. This one explicitly says like rationalize the denominator. This one doesn't quite give you that hint, but you've got to realize to do that and then use the rules of surds that we've previously learnt to deal with it. But that is it. So basically, I mean, I suppose if I'm summing this up, we can write that b over root k equals b over root k times root k over root k equals b root k over k. I can always rationalize my denominator by timesing by the top and the bottom by this root k. Okay, I've done so here. Sometimes it will then simplify down. Sometimes I may need to still do some other things with k if it's like if it's 8, for example, but this illustrates the idea. We're not quite done with this topic, but we are for this lesson. But next time we're going to look at what if the denominator wasn't just a surd like this by itself, but what if it was a surd plus a number? And then we'll see that something slightly different happens. So I don't want you to think rationalizing the denominator, I always multiply by the thing that's on the bottom, but basically if it's root k, then you will.